everyone. Thanks so much for coming to this last presentation of the day. Today I'm going to talk about redefinition in ECMAScript. This is a short talk about a specific class of bugs that I've been finding a lot of lately and I think is a little bit underdocumented. So today I'm going to explain what I mean by redefinition in ECMAScript and the sort of problems it can cause. I'll also go through some bugs that I found that involve redefinition and explain how they work and how to reach them. But before I begin, I should introduce myself. I'm Natalie Silvanovich, and I'm a security researcher on Google's Project Zero. And I'm a Flash enthusiast, and I'm an ECMAScript enthusiast, and I love making the sad puzzle piece appear. So to start off, I'm going to give a quick example of what I mean by redefinition. This piece of code in JavaScript for your browser has two functions. One is document.write, which is wrapped by this function f, and that's the function that puts text on your screen in the browser. And then there's a second function here, alert, and that's the one that spawns the modal dialog with the dismiss button. And I'm doing alert equals f, alert equals document.write, and then calling alert. And there's really three things that can happen here. Behind door number one is that the original function, alert, fires. Behind door number two is that the second function, document.write, fires. And then the third possibility is that the browser just kind of gives up on executing script. And what happens, at least most of the time, is this middle case. Usually when you do f1 equals f2 in a browser and then call f1, it's actually f2 that executes. And that's what I'm going to talk about. Although sometimes these other guys happen. And this depends on your browser and your ECMAScript implementation, and also specifically what function you're trying to overwrite. So there's interesting bugs with the middle case. So I'm going to talk about those bugs, and also, if you're happening to get the two side cases, how you can get yourself towards this middle case and reach an issue that is happening due to redefinition. So what I'm going to talk about more specifically is what happens if a function gets redefined that the virtual machine relies on. What if the virtual machine is executing ECMAScript and it's in a native function, and then it needs to call into ECMAScript again for a different reason? For example, let's say there's a callback or some function that's only described in ECMAScript. And what happens is that sometimes the virtual machine makes assumptions about what will happen. Sometimes it assumes that this function has not been overridden, even though it has. And this can lead to all sorts of interesting issues. I've seen use after freeze, I've seen overflows, I've seen type confusions, all sorts of bugs. I've heard these types of bugs called reentrance vulnerabilities, but I don't really like that term because reentrance isn't always required. Sometimes all that's required is redefining a method and then calling something else, and that's it. Flash seems especially susceptible to these types of issues. On Project Zero, we've found 24 of them in the past 6 months. Most of them are in ActionScript 2 because that's the ECMA implementation that allows the most to be redefined, although there's also been a few bugs in AS3. And I'm definitely not the first person to think of this. In fact, the first time I heard of such a thing was at Woot in 2009. And there was this talk where basically the authors were able to bypass same origin policy by using redefinition. They made one function equal to a function they defined, and then this was called in a different context, and the script was actually executed in that context. And this sort of thing still happens. There's actually a similar issue, this JS privilege escalation in Firefox in 2014 that involved function redefinition. But there's also these memory corruption issues that can happen due to VM assumptions. And there's been 2 of them that I know of. There's probably more in the past 2 years. There was an overflow in Chrome, and there was a use after free in Firefox. And recently, there was the hacking team dump, and there were 5 issues in Flash discovered in this dump, and actually 4 of them involved function redefinition, which shows that this is really a type of attack that is used by attackers in the wild. So how do you actually redefine a method? The most simple way is using the equality operator. And this is the easiest in ActionScript 2. In ActionScript 2, everything can be redefined as everything. There's no guarantee this will compile. Sometimes you have to write the bytecode by hand. And sometimes there's read-only properties, so you have to fix them using this method called ASSetProps. But in ActionScript 2, anything can be defined with anything. JavaScript is basically the same. JavaScript can redefine anything as anything with one exception. If you try to redefine one native method as another native method, it will not work. So you need to put a wrapper around the second native method. And that's why I had the wrapper in the example I showed at the beginning. But this doesn't really actually stop you from doing anything. It's just you need to make sure you remember to put the wrapper around the function before you redefine it. ActionScript 3 is much more restricted. Classes need to be defined with basically the dynamic keyword for functions to be able to be redefined with equality. But fortunately, there's a lot of other ways you can redefine stuff in ActionScript 3, which I'll talk about later. So to give an example of this type of bug, I'm going to go through this bug in filter processing. And just as I start going through the bugs, I want to mention that these were all reported to Adobe and they've all been fixed. And I really appreciate that they fixed these issues quickly. I'm not going to go through the history of every bug, but don't worry, they've all been fixed. So this issue is in this filter setter for a button object. And what this code does is it starts off by creating a blur filter. And then it calls the filter setter on the button object and sets it to the filter. And what this does in the VM is in the button object, it creates an array to hold these filter objects, and then it copies the blur filter. And then what I do is I redefine the blur filter constructor as the convolution filter constructor using equality. And then this code calls the getter. And what that does is that copies the filter out of the button array back into a temporary array, and then it tries to create an ActionScript object to point to it. But what happens here is because the constructor for that ActionScript object has been redefined, it actually calls the wrong constructor. And this is type confusion because you have a convolution filter in ActionScript pointing to a blur filter backing object. And just to give a feeling of what's happening here, this is pseudocode for the VM. Basically, it's taking a blur filter and casting it to a convolution filter. So this can often mean that integers are confused with pointers, pointers are confused with integers. It's actually a fairly bad bug. To give a second example, this is another Flash issue, and this is one where I had to do a bit more massaging to actually make it compile. So you can see I have this var b equals flash.net, and then b.fileReference equals q, and then q is actually a wrapper around the bitmap data constructor. But what this is actually doing is, once again, just redefining the file reference constructor as the bitmap data constructor. And then what this bug does is I create the file reference list, and then I call browse on it. And that's the function that brings all the files up on the screen so you can select one. But then when you select one, it tries to create this file reference object to hold the name of the file you selected. But since the constructor has been overridden, it actually creates a bitmap data object. And once again, that's type confusion. The code starts assuming that the object was created was a bitmap data, was a file reference object when it was not. So not every ECMAScript implementation supports equality, and not every method supports equality. So another option you have is to use a proxy object. And these are in JavaScript and ActionScript 3. And they basically allow methods that handle variable access to be defined. And you can basically define everything. You can define what happens if a getter gets called, what happens if a setter gets called, what happens if an unknown field gets accessed, what happens if you enumerate, whatever. And these have caused a few bugs in Firefox. So I've got an example of a bug in Flash here. This was found by Ian Beer. And this was actually in the open source components of Flash. So I have the VM code. So starting with the VM code of this stringify function, what it does is it takes an object in ActionScript and it enumerates over it to figure out how many fields it has, how many properties it has. And then it allocates an array based on that number of properties, and then it enumerates again and copies them into the array. But what it doesn't account for is what if this is a proxy object? So it's easy enough to implement a proxy object where the first time you enumerate it, it's really small, and then the second time you enumerate it, it's really large. So basically it enumerates Alex, and then the second time it enumerates, it's way too big, and you get an overflow. Another interesting way you can redefine stuff, if you can't use equality, is using conversion operators. And these are pretty interesting. They're implemented in ActionScript 2 and also to some extent in JavaScript. And basically they're used for conversion. So the two most common of them is value of, and this is called when you need to convert an object to an integer. And there's toString, which is used to convert an object to a string, and this is used very frequently for logging. And what's really interesting in ActionScript is if you call a function, for example, where one parameter is a number and then the other parameter is a string, a lot of the time, if you provide something that's not a number as the first parameter, it'll call value of on it. And if you provide something that's not a string as the second parameter, it will call to string on it. So this can cause a lot of interesting bugs. For example, there's this bug, it's the convolution filter bug. And this kind of has an interesting history. I found it in February, and then a very similar bug was used to win Pwn to Own in March, and then it turned up in the hacking team dump. So at least 3 people independently discovered this bug. And the way this works is it involves using value of with the filter matrix setter. And what this setter does is it basically takes an array from ActionScript and then copies it into a native array. And the actual order of operations is you call the setter, it deletes the original matrix, and then it reallocs the new matrix, and then it copies the numbers into the matrix. Well, what this bug is you call the matrix setter, and it deletes the old matrix, it reallocs the new matrix, it copies the numbers, except the numbers aren't actually numbers, so it calls into value of, and then it calls the matrix setter again. And then this deletes the array, reallocs it, copies in the new array you provide as the parameter, and then it returns, but wait, the array you're currently copying into has already been deleted, and that's a use after free. So this is an example of what you'd call a reentrance vulnerability. It's one where if you go into a function twice when it's not expecting that, you can change properties in an unexpected way, and it leads to a bug. Here's another example of a bug that involves value of, and this was found in the hacking team dump, and it was also part of the open source Flash component, so there's code for it. And this one's in ActionScript 3, and it involves redefining value of, although you'll notice in this case, you actually have to extend the class, create a subclass to redefine value of, but that's easy enough to do in this case. And this is in the index array of the byte array class. So you call b sub 0 equals n, and n is an object that has value of redefined, and it gets converted to an integer so it can be converted to a byte. So it's probably easiest to see what's happening here from the VM code. The first thing that happens is there's this byte array object, which is the native byte array that backs the ECMAScript object, and it is indexed at the index you provide, and then that's just a pointer. And then the right side gets evaluated, and it calls into this integer function, which calls value of. And then that can do something such as changing the array length that causes it to be realloced. And then it writes just 1 byte back to that array that's been freed, which is a pretty small use after free, but it was enough for a working exploit. So another interesting function that can cause redefinition issues is watches. And these are things that can be used to interfere, especially when a property is set, especially inside a native function. So specifically what a watch does, you can see the call to watch in this example, and basically you specify the property of an object, then you specify a function, and every time that object then gets set, this function gets called, and you have the opportunity to either return what it was set to, and then that won't change the property, or you have the option of returning something different, and then that will change what the property got set to. So this specific bug is once again in this file reference list. And one subtlety here is that you can't set a watch on something that doesn't exist. So I have to create the property file list first and then set a watch on it. And then I call browse, which is once again the thing that makes all the files appear on the screen. And then when you select a file, it tries to create this file list. Except since it's already been created and has a watch on it, the watch gets called. And then the watch can return something different, which is of the wrong type, to the function. And then this is type confusion. Specifically, this integer will get interpreted as a pointer because it thinks it's an object that's being returned, but it's not. One more example of this is this net connection bug. And this is an interesting one because this is kind of a time of check, time of use bug. So to start off, I create the property so that I can set the watch on it, and then I create this net connection and then set it to the proto. And this is just to pass an unrelated check in the connect function. And then I call the connect function. And the first thing the connect function does is it makes sure that the thing that's coming in is of the right type, of this net connection type. And then it sets the URI. And the URI, because it has a watch on it, calls into this function, which is once again just a wrapper around the bitmap data constructor, which then basically redefines this object so that it's now a bitmap data object. So then when you return to the main function, it's a bitmap data object, except the function assumes it's a net connection object, and that causes problems. So basically, this is bypassing the check. The check happens, then you call into the URI, and it changes the situation so that the check now is violated, and then it makes other calls with that assumption. So now I'm going to go through a couple of other methods that I think are possible to use to cause these types of issues. These are ones either where I haven't found a bug yet, but I think it's possible, or 90 days hasn't passed on that bug yet. The first one is subclassing. In fact, the byte array issue I showed you did use subclassing, but I think there's more things that could be used in subclassing to redefine methods other than just value of. In particular, I think there could be situations in virtual machines where they check that something is of type X, but really it might be a sub X, and then that could be used to redefine methods in ways that are unexpected. Basically, in ActionScript 3, any non-final properties can be replaced with other methods or getters or setters. So I think this is a possible way to cause bugs by redefining functions. Another possibility is __ resolve, which is it's __ resolve in ActionScript 2, and then it's __ lookup in JavaScript. And these are what I call last resort functions. These are, if something is undefined, they will get called. So for example, if you define resolve as a method in ActionScript, and then you call on that object a field that doesn't exist, resolve will get called. So these are useful in two different ways. They're actually a good way to find this type of issue, because if you don't set any properties on an object and then you set resolve and then you put logging in there, you can actually use it to figure out in a native call what stuff is actually getting accessed by the virtual machine. So that can be an interesting experiment just to see everything that's getting called. But also this could be used to redefine methods as well. Maybe if the virtual machine calls into them and accesses a property that doesn't exist, maybe it's not expecting that it's defined with resolves and unexpected behavior will occur. The last one is getters and setters. And these are functions that can be defined that execute script when they're called in general, including by native functions. They can be done in ActionScript 2, ActionScript 3, and JavaScript using different functions. And there actually was an issue in JavaScript in Chrome that was caused by this situation. It was an issue where for a certain object, a getter and a setter for length was defined when the code assumed that length was just a property. And what that meant was that the getter and setter could return a different value for length each time. And once again, this was an overflow where the first time it returned the value, it was small, and the second time it returned the value, it was large. But I think there's a lot of possibilities for getters and setters in finding these types of bugs, not just by returning something different time for fields, but there's also the possibility that they can execute script when it's unexpected and change properties in objects and maybe bypass checks or do other things that are unexpected. And I think this is mostly something that will impact JavaScript, though. In Flash, and this is actually well documented, the native use of getters and setters is fairly uncommon due to optimization. So usually if a native call is expecting something to be a field, it won't call a getter or a setter if it's not supposed to be there. So the last thing I'm going to go through is how do you actually find these types of issues? And there's a few different ways. One good way is code review if you have the code. If you can find functions that cause calls into script or call fields or access fields of an object, that sort of thing, it's easy enough to figure out where the calls into these things that cause script execution are, and then use that to find areas to look for these types of vulnerabilities. Another possibility is using reverse engineering. I actually think the majority of these types of bugs are found using IDA, and this is the same concept. Basically, if you can find the function in IDA where there's calls into script or where object properties are accessed, you can use that to find where places where it's a good idea to look for these types of bugs. Another possibility is the API docs. Once you've seen a few of these types of bugs, just by reading through the API, it can be evident where other good areas to target are. In particular, if a function takes an object or an array as a parameter, that's usually a concern because you know that the object is going to need to be converted into some other type. Or if it's an array, then the things in the array are going to need to be converted to another type. And that could lead to calls to value of or toString, which can cause a lot of problems. And finally, specialized fuzzers. It's funny, I've never actually met anyone who's done this using a specialized fuzzer, but when I talk to people, everyone always knows a guy who has a fuzzer that does this sort of thing. So while I've never personally done this, I think that it's actually a strong possibility you could find bugs using fuzzing if you had a fuzzer that had a strong understanding of both how you can redefine methods and of what methods a specific ECMAScript implementation supports. So that's it. In conclusion, ECMAScript is largely too dynamic for its own good. While redefinition is a useful feature in a lot of different situations, it's important to be careful when implementing it to make sure that it doesn't cause a lot of security problems. And while this research is specific to ActionScript, there's nothing I think in here that's actually specific to Flash. Other ECMAScript engines can and have in the past had similar issues, and I don't think they're all gone. So I'm going to end with the thought to go forth and find bugs. Whether you're a developer who's responsible for maintaining an ECMAScript engine, or whether you're a security researcher who's responsible for reviewing one, it's important to understand how redefinition can affect your security model. Doing so, I think, could help you find and fix a lot of bugs. So that's it. I'd like to open the floor for questions now. And also, I've got my contact info there, so if you're shy, feel free to contact me if you have any questions. I love answering them. Sorry, can you repeat that?
Do any of the modern JavaScript frameworks, such as AngularJS, have pitfalls that you see?
He asked if any modern JavaScript engines such as AngularJS have these types of issues, or if I've just focused on Flash. Personally, I've just focused on Flash, and I went through some old bugs to see if I could find similar bugs in other frameworks. And I've seen a few in browsers, but like not at the quantity that I saw in Flash.
Funny results, or is that mostly protected against?
Yeah, sorry, the mic just turned on in the middle of the question, so.
Oh, sorry. Hi. Did you do any research into like manipulating sort of the pseudo variables that are provided by the VM, like the arguments pseudo array for variadic functions, and like maybe manipulating, or is that mostly protected against now?
Yeah, I did try playing with that a bit, and it's fairly easy because of function.apply that's supported by a lot of the ECMAScript engines to play with that sort of thing. And while I played with it, I haven't found any bugs recently in that. Oh, is there another question, or? Oh, sorry. Sorry, what? Yeah, he asked if I'd tried using the function keyword for late redefinition, and no, I haven't. So any more questions? Sorry, if I understand correctly, you asked if what this type of bug looks like in the C code that actually implements the function. Yeah, I had a couple of examples in there, but typically, basically what it looks like in the code is that there is some sort of function that gets called that can cause, in some situations, a call into ECMAScript, typically. So there are functions you can look for in the code that are kind of indicative that this sort of problem can occur. Okay, I think that's it here. Thanks a lot, everyone.